As you can see, my gyroscope can bounce pretty well on the tip of a pen. But why? How is this possible? This is possible due to the conservation of angular momentum. Angular momentum is defined as the cross product of linear momentum and the radius vector. To determine the direction of angular momentum, use your right hand and give a big thumbs up. Your fingers will point in the direction of the spin, and your thumb will point in the direction of the angular momentum. But why does this right hand rule work? Well, if you pick a certain point on the gyroscope, you can find its linear momentum and its radius vector. Now you can find a vector that is perpendicular to both the radius and the linear momentum. This is the angular momentum. Now, to explain why a gyroscope is so stable, first picture a ball moving in one direction. This ball will have a definite momentum. If you apply a force to it, this will change its momentum. The change in momentum is called impulse. Now this makes sense because impulse is defined by the force multiplied by the change of time. This property is also displayed by a gyroscope. In order for its angular momentum to change, there needs to be applied force, and the change of momentum is impulse, and this is defined as the torque times the change in time. And torque itself is defined as the cross product of force and the radius. So what this mumbo jumbo means is that a force is needed to change the angular momentum, otherwise it is conserved and it will keep the same orientation forever. Well, theoretically speaking, forever. Now, as you can see, if my rotating gyroscope is placed on a tilt, it begins to spin around an invisible axis. This is known as precession. So why does it happen? First, let's talk about torque. Now torque, as stated before, is the cross product of force and radius. You can find the direction of torque by using another right hand rule. So place your index and middle finger in a 90-degree angle and place your thumb up. Your thumb represents the direction of torque. And as stated before, the impulse or change in angular momentum is the product of torque and the change over time. And since torque is multiplied by a scalar value of time, torque and impulse have the same direction, which is 90 degrees to the angular momentum vector. Now this is the bird's eye view of the precessing gyroscope. If we start off with the initial angular momentum vector, we can find a vector perpendicular to that. This is the impulse. And by using vector addition, we can find the resultant, which is the second angular momentum vector. Now this vector addition is happening at every instant of the gyroscopic precession. In fact, if you trace the impulses, it makes a circular path, which explains why the gyroscope spins around and precesses.